Right now I'd like to talk a little bit about the art of reporting bugs. So let's assume that you're successful creating some sort of really nice random tester that starts crashing utilities. So let's say, for example, that you want to do your own fuzzing study. So if you recall, a fuzzing paper was written in 1990, one was written in 1995, then another in 2000, another in 2006. So now it's 2012 and it's basically time for a new one. So you do it. And so what you do is you go take whatever operating system you choose and you start crashing software. And hopefully, instead of just being happy about what a successful effort you've had, you'll report the bugs to the maintainers so they can start improving the robustness of their software. And so let's talk about how to do that. So the first rule, and it's really simple, is don't report a duplicate bug. The way to avoid reporting duplicate bugs is to go to the bug reporting systems that most open source projects maintain and search on some symptom of the bug that you found and see if it's been reported. So let's say we found a way to get a segmentation fault out of LLVM. Let's see if anybody else has done that lately. Well, okay, so we only have one reported here. So that's really nice. So it might be safe. So what we would do then, if we want to report a new segmentation fault in LLVM, is we go ahead and look at this and see if the new one that we're going to report seems to be sufficiently different. If it is, then we probably go ahead and report it. The next golden rule for reporting bugs is to respect whatever the local conventions are of the community that you're reporting to. And so the best thing to do here is just look for some bugs that have been reported and see what kind of discussions they generate and try to take sort of a similar tone to what people have already done. The third thing is to report a small test case. I'm going to say here a small standalone test case. So the test case minimization stuff that we talked about a little bit earlier is really important for purposes of bug reporting, and that kind of a process should always be part of your bug reporting. And the second clause here, a standalone test case, is also really important. So this means, for example, don't report a bug that depends on some other file that only exists on your machine, because that's not very useful to the people who are going to try to reproduce the bug, because of course they don't have the other file. So do what you can to make the bug report standalone. The next rule is only report valid test cases. And so this is referring back exactly to the input validity problem that we've been talking about, that I talked about a number of times in the material on random testing. And I mean, if the software to which you're reporting bugs isn't supposed to programmatically reject invalid inputs, then you shouldn't report an invalid input. And so an example of a system is, for example, a C compiler isn't supposed to reject invalid inputs. And another example might be something like internal communication between a JavaScript engine and a web browser. There may not be total input checking on some sort of an internal interface like that. And so basically, we just want to be sensitive to the fact that some systems can't do or aren't equipped to do full validity check of their input. And for those systems, we often need to make sure the input is valid ourselves by hand. Now, of course, other systems, and we've talked about things like Acrobat Reader or whatever, these are supposed to reject invalid input and they're not supposed to crash some sort of a buffer overflow, even on invalid inputs. For those kind of programs, this issue doesn't really exist. The next thing you need to do is tell the people who are the recipients for your bug report what the expected output of the system was, that is what you hoped would happen if the system wasn't buggy, and then what the actual output was, that is to say what really happened on your system. And so the temptation is to not supply these things because you think that's insulting or you think that's really obvious, but in general it's a good idea to err on the side of caution and include these things. So you might include a bug report to the Python maintainers saying that when I added 1 + 1, I was really expected 2, but then this particular version of the implementation printed 3. The next thing you need is to make the failure reproducible, because nothing will get a bug report ignored faster than being completely irreducible. And so you need to include things like platform details. So for example, it's probably crucial information that you're running Firefox on Windows as opposed to Linux if you are trying to report some sort of a Firefox crash. The exact version of the software under test is important. And of course, if this is some sort of an open source project that you've hacked yourself before compiling, you will definitely need to include details about that in the bug report. Because if the bug is your fault, then you don't want to waste people's time trying to track it down. So, summary is if we're able to come up with good, solid answers to all of these requirements, then it's a great idea to report a bug. And so let's go ahead and go do that right now.